Hello and welcome to another physics tutorial. Given that acceleration, that a is equals to minus 4 over t raised to the power of 3, that's t cubed, and that the velocity is 2 meters per second, and the displacement is 0 when t is equals to 1. Find the displacement when t is equals to 4. Another question we have here is for us to show that the velocity is always positive, but the displacement never exceeds 2 meters. All right, so in this case, the first thing to do is to find the velocity function. But first, we need to understand that we're able to find the velocity function because we know that acceleration can be defined as the rate of change of velocity. So we need to integrate this function. This is the acceleration function. Okay, so first thing to do, because we are giving acceleration to be equals to negative 4 over t raised to the power of 3. And also because we know that acceleration, okay, acceleration, that a is defined as the rate of change of velocity. Okay, so that means that from here we know that acceleration is dv over dt. So which means I'm going to write a to be what? As what? dv over dt. So dv over dt equals to minus 4 over t cubed. Now to integrate this, I will need to first multiply both sides by dt. So multiplying both sides by dt. So dt multiplied by dv over dt, this will be dv, okay, equals to negative 4 over t cubed, then dt. That is because dt multiplied by dv over dt we cancel dt, so that we can have dv on the left hand side, while on the right hand side we will have minus 4 over t raised to the power of 3 dt. Now this is when we can now introduce the integral sign. So now integrating both sides, integrating both sides. So we have the integral of dv equals to integral of minus 4 over t cubed with respect to t, then plus, so this is the first, we have our first constant of integration because we have here that the displacement is 0. So which means we are also going to write the displacement function equation using the velocity, because velocity is defined as the rate of change of displacement. So let's get the value of t first. Now integrating 1 dv, that will be v. Let me continue from here. So we have v to be equals to, that is v of t will be equals to, integrating this, we then have negative 4 raised to the power of minus 3 plus 1 divided by minus 3 plus 1, then plus constant of integration. This is when we apply one of the rules of integration. You know, if we have integral of x to the power of n dx, this will be ax raised to the power of n plus 1 divided by n plus 1 plus the constant of integration. Okay, now, so from here we have our velocity function to be, this is minus 2, so we have negative 4 over minus 2, minus 3 plus 1, this will be negative 2, then plus the constant of integration, so that the velocity function will be 2 t raised to the power of minus 2, okay, then plus c1, which is a constant of integration. Okay, now we need to find the constant of integration because we are yet to what, to get the velocity function equation. So now in the question we have that given that acceleration is equals to this and that the velocity is 2. So when v is equals to 2, okay, and the displacement is 0 when t equals to 1, the value of t equals to 1. So we have at v equals to 2, t equals to 1. So it means that we're going to have 2 equals to 2 into 1 raised to the power of minus 2 plus c1. So this will be 2. So we have 2 equals to 2 plus c1. So that c1 will be 2 minus 2, which is 0. So which means the velocity function will be 2 over t squared. This is the velocity function. This is the velocity function. Okay, now, again, we have that the displacement is 0 when t is equals to 1, and that we should find the displacement when t is equals to 4. Now, to be able to derive the equation for displacement function, like I said, we need to use the fact that velocity can be defined as the rate of change of displacement. So we have that since velocity is or can be defined anyone as the rate of change of displacement, that is, velocity will be ds over dt. So which means velocity function in this case will now become ds over dt equals to 2 over t squared. Okay, now again, before introducing the integral sign, I will need to get rid of dt from the left hand side. So I'm going to multiply this by dt. So multiplying this by dt, we're going to have dt multiplied by ds over dt. This will be ds. And this will be equals to dt multiplied by 2 over t squared. This will be 2 dt over t squared. Now I can introduce the integral symbol. Okay, so now integrating both sides. Okay, we have that the integral of 1 with respect to x, this will be 1 ds, will be equals to integral of 2 over t squared with respect to t plus, so now we have the second constant of integration. Now we have our value for c1 to be equals to 0. So since we are integrating again, so it will now be c2, okay, because it won't be the same value. It's not possible. So in this case, this will be s. So this will be displacement function equals to 2t raised to the power of minus 2 divided by minus 2 plus 1, then plus c2, which is the second constant of integration. So we have negative 2 plus 1, that will be minus 1. 2 divided by minus 1, that will be minus 2. So which means that the displacement function will be negative 2, okay? Now, minus 2 plus 1, that will be minus 1. So in this case, this will be negative 2 over t, then plus c2. Now, okay, we have here that the displacement is 0 when t is equals to 1. So when the value of this guy is 0, then the value of t will be 1 according to the question. So this will be 0 equals to negative 2 over 1 plus c2. So which means that c2 will be equals to, now this is minus 2 over 1, that will be minus 2. And I'll move it to the left hand side, as I'll carry it to the left hand side to become plus 2. So c2 will be equals to 2. So which means that the displacement function will be this guy minus 2 over t plus 2. So I can write this again to be equals to 2 minus 2 over t. This is the displacement function. Okay, all right, now we are done. Now another question we are asked is that we should find the displacement when t is equals to 4. So at t equals to 4, we want to know the value of the displacement. So which means S4, because now we have the value of t to be 4 will be equals to 2 minus 2 over 4. So that S of 4 will be equals to 2 minus 0.5. 2 divided by 4, that will be 0.5. And then this will be equals to 1.5 meters. So the displacement when the value of t is equals to 4 seconds is 1.5 meters. Is 1.5 meters. This guy. Nice. Now, we are asked to show that the velocity is always positive, but the displacement never exceeds 2 meters. Very simple. Now, to show that the velocity, the velocity, which is what we have to be v, that is v of t equals to 2 over t squared, is always positive. Is always positive. That is because reason number one. Now, for all t greater than or equals to 1, for all t greater than or equals to 1, now t squared will be greater than 0. That's it. Okay. Then Roman numeral 2. Also, for all value of t greater than or equals to 1, okay, we can also have that constant 2, okay, is always positive. Is always positive. So this shows that the so this shows that v of t, okay, is greater than 0. So therefore the velocity function is always what? Always positive. Is always positive. That's it. Okay. Now also, but the displacement never exceed 2 meters. The displacement never exceed 2 meters. Let's find out. Now, to show that the displacement never exceeds 2 meters. What does that mean? We have the displacement function. We have the displacement function to be 2 minus 2 over t. So which means that in this case, okay, I can also say that for all t greater than or equals to 1, yes, for all t greater than or equals to 1, 2, yes, 2 over t is always positive. Yes, it's always positive. Also, for all t greater than or equals to 1, that means that if I set the limit, the limit of st as t approaches infinity, then this will approach 0. Okay. So which means that the limit as t approaches infinity of 2 minus 2 over t. Okay. 2 minus 2 over t. Okay. So this shows that now this is just like having a positive number, okay, a positive value subtracted from 2, and that means we're going to get a value which is less than 2. Now, which means that the displacement will increase towards 2 but never exceed 2. Yeah, yeah. So which means in this case, when we put t as infinity here, this will be 0. Okay, so this will be equals to 2. So which means that it never exceeds 2. So I will then say that the displacement increases towards 2 but never, yeah, never exceeds 2 meters. Yeah, never exceed 2 meters from here. Never exceed 2 meters. Of course, will still be greater than 0. All right. So which means which means that when we set the limit that this displacement function as t tends to infinity, okay, then we have the value to be equals to what? 2. So it tells us that the displacement increases towards 2, but never what? Never exceed 2. The noblest pleasure is the joy of understanding. Bye-bye.